Good evening. In continuation to our earlier video on shift registers, today we are going to study our topic on parallel in serial out shift register and parallel in parallel out shift register. Now, first let us consider parallel in serial out shift register. This is the diagram 4-bit shift register. Again, like we had earlier discussed, in this we can see that we are having 4 flip-flops and some additional circuitry is being provided in this. As we can see, gates, these are the gates in which we have 1 2 3 4 5 and 6. These are the AND gates, and in addition to that we have 3 OR gates also. This one and this one, these are OR gates. This is shift oblique load bar. Two operations are there. One operation, that is shift 1 for shifting the data, the load bar for loading the data, and this will work when active low input is given over here. This is the NOT gate. Now let us consider the data as 1011, and here initially we will consider the parallel inputting of the data. So the data which we are considering is 1011. So for that, here we will apply 0, and this will cause gates, as you can see this is high, so gates 1 2 and 3, the gates 1 2 and 3 AND gates, these will be enabled, and gates 4 5 and 6, these will be disabled. Okay, we have to keep this in mind that gates 1 2 and 3 are enabled. Now let us see. Okay, again here we have to apply the clock also. So again, there is a common clock which is connected to all the flip-flops. Now when you apply this 1 to this D input of this flip-flop, it will store 1. Okay, now when this 0 is applied to here, it is 0, and from here we are getting 1, so this will cause it to be this is AND gate, here it will be 0, and since this gate is disabled, so output of this again will be 0. So finally this is OR gate, so 0 plus 0, this will store 0, so the output of this Q1 will be 0. So Q1 is storing 0, Q0 is 1, Q1 is 0. Now let us see. Here we are having 1, this is 1, this is 1, so the output of this is gate 2 is 1, and the output of this is 0. So this is OR gate, 1 plus 0, here we are getting 1, so Q2 will become 1. Now let us take this one, this is 1, this is also 1, both the inputs, the third gate is 1, so the output will be 1. So this is 0, and 1 plus 0, this will be 1, so this will cause, here it is 1, so this will cause Q3 output to become 1. So as we can see that Q0 is 1, Q1 is 0, Q2 is 1, Q3 is 1. So this is what 1011 is the data which we wanted to input in parallel manner. So now let us take serial outputting. So for serial outputting, here we have to apply 1. When we apply 1 over here, this will cause gates 4 5 and 6 to be enabled, and gates 1 2 and 3 in this case will be disabled. So now let us see what happens. We apply the second clock pulse. On application of the second clock pulse, what will happen? The one which was here will get 1, and since this is 1, this is an AND gate, so this will be 1, and here we are getting 0. Okay, so the output of OR gate will be 1, so here 1 is being applied, so this will cause Q1 to become 1, just like I have written over here. And second clock pulse, what will happen? Q0 will be nothing, Q1, as you can see, this will be forced to become 1, and now this 0, here we are getting 0, here we are having 1, so the output of this will be 0, here we are having 0, so both of these inputs to OR gate is 0, so finally here 0 is being applied, so this will cause Q2 output to become 0. As you can see, Q2 will become 0, and this 1 over here, this will go to this input, here we are having 1, so this is 1, this is 1, so output of this AND gate will be 1, and this is OR gate, so this output will be 1. When this 1 is being applied to this input, it will cause Q3 to become 1. So that is what we are getting. Q0 as nothing, Q1 will be 1, Q2 will be 0, Q3 will be 1 in the second clock pulse. Similarly, likewise, in the third clock pulse, it will be, the bits will shift one by one, the bits will be shifted in this manner. In the fourth clock pulse, we can see that Q0 will be nothing, Q1 will be nothing, Q2 will be nothing, and Q3 will finally hold 1, and that is the main serial output available. So this is all about the parallel in serial out shift register. Now let us take the parallel in parallel out shift register, which is in fact the easiest of all the 4 shift registers. This is the diagram of the PIPO, we call it in short, parallel in parallel out shift register. Here, as you can see, the same data which we had considered in the previous shift register, that is 1011, is being applied. So this is the easiest of all the 4 shift register, since as soon as we apply the data 1011, it is available on the respective input lines, as well as it is also available on the respective output lines of the respective flip-flops. Just like here we have D3 is equal to 1, D2 is equal to 0, D1 is equal to 1, D0 is equal to 1, and these inputs are simultaneously available on the respective output lines also. That is, we are getting Q3 is equal to 1, Q2 is equal to 0, Q1 is equal to 1, and Q0 is equal to 1. So this is how the parallel in parallel out shift register working takes place. That is, here we can, a point to note is that in a single clock pulse, the parallel inputting as well as parallel outputting is taking place. That is, this is the parallel in parallel out shift register. Thank you.